All right, here we go. Here's my epic video, hopefully, on inverses. So we're going to do a lot with these two functions. Um, f of x is the fourth root of 3x minus 10, and g of x is this with the domain of x is greater than or equal to 0. So first of all, we're going to look at the graphs of these and verify that they will have inverses, and then we'll talk about this x is greater than or equal to 0. So here's what the graphs look like. It's important to look at the graphs. So f of x, which I'm going to show right now, looks like this. Kind of like the square root graph, which makes sense because it's a fourth root graph. Now, it's a function of x because it passes the vertical line test. A function has an inverse if it passes, well, first of all, it has to be a function, and it also has to pass the horizontal line test, meaning it's 1 to 1. So we're also going to run a horizontal line through this just to make sure it passes that one. So it's the same as the vertical line test. If it only hits in one spot, it's going to be 1 to 1, and thus it has an inverse. So that function definitely has an inverse. So that's how you're going to look at the graphs to see if they have inverses or not. So now I'm going to look at g of x. G of x is definitely a function of x. It passes the vertical line test. But when you run it through the horizontal line test, it does not pass. So we have a problem. This doesn't have an inverse. So talking about inverses is going to be difficult. And that's where this comes in. They restricted the domain on this function for x has to be greater than or equal to 0. And the reason why that was necessary is just this fact. It doesn't pass the horizontal line test, so it doesn't have an inverse. So if you look over here to the left, I'm going to restrict the domain just like they said. I'm going to say x is greater than or equal to 0. And oops, I put 0. So now look what the graph looks like. It cut it in half because it restricted this domain here. So now when you run the horizontal line test, it does have an inverse. So that's graphically how you tell if functions have inverses or not. So now that we're past that, another thing with the graph we should say, um, you can tell if two graphs are inverses of each other, or you can get a hint if they're inverses of each other if they are reflections along the line y equals x. So let's just check these two functions out to see if they have a chance to be inverses of each other. There's the two functions. I'm going to plot y equals x, which is just a 45-degree angled line. And if you fold this graph paper along that line, these graphs are going to completely cover each other. So they are reflections, apparently. So it looks like they may be inverses. So that's everything really you need to know about graphs of inverses. Now we're going to do algebraically show that they are inverses. And to algebraically show that they're inverses, you have to show that f of g of x, something you're used to doing, is going to be x. And g of f of x is also going to be x. In other words, inverses undo the original function. So if you plug in x for g and then apply f to it, it's just going to come back as x. Same thing with the reverse. So f of g of x, let's do that first. That means plug g in for f. So we'll have the fourth root of 3. And now instead of x, we're going to use g. So it looks like it's going to be a mess. And then minus 10. So I just plugged this function in for x. Well, the nice thing here is 3 times this whole fraction, it's 3 over 1, so we can just cancel out these 3's. So now we have no fractions to deal with. So we have the fourth root of x to the fourth plus 10 minus 10. And we have the fourth root of x to the fourth. And the fourth root of x to the fourth is, you usually right away think it's x, but it's really the absolute value of x. But remember, we restricted the domain for x is greater than 0, so the absolute value of x for x is greater than 0, since it's positive, is just x anyhow. So because x is greater than 0, you can say that the fourth root of x to the fourth is x. So that's a check right here. Now we have to do this one. So g of f of x, we need to now plug in f to g, so it's just the opposite. We're going to move that. We're going to take f, which is that, and plug it into g. So we will have, instead of x to the fourth, we'll have the fourth root of 3x minus 10 to the fourth plus 10 over 3. Fourth root to the fourth, they just cancel out. This fourth root to the fourth will cancel out this fourth root, so you just have 3x minus 10 plus 10 divided by 3. This is going to work out really nicely. 3x plus 0 over 3, and 3x divided by 3 is x. And we have now just proven that f and g are inverses of each other. Next, we're going to calculate inverses. So we're going to use the same two problems. So we're going to find the inverse of f. Now, no, we already know what it's going to be. It's going to be g, we hope. But let's actually calculate that ourselves. So ignore that. Start with f. So one way you can do this is just flip the x's and y's, and I'm not going to do it this way, but I think it's more work than required, but let's just show you. You can flip the x's and the y's, and now just solve this for y, and you'll have the inverse. Most of that you can do in your head, and that's what I like to do. I like to do it all in my head. So we're going to say the inverse of f is, you always just start with an x. And now you undo this. So pretend you're solving for x. Undo everything around the x and use your reverse order of operations. So wait. So the first thing you have to do here is, ignore this for a second, because first thing you have to do here is get rid of the exponent. Or not the, well, it is an exponent, but it's the same thing. It's a root. Otherwise, you won't be able to free up that x. So to get rid of that fourth root, you're going to have to do the inverse, or raise it to the fourth. So I'm going to raise it to the fourth, and now that's gone. So now we're going to solve it. Take care of this subtraction first. So it was minus 10. I'm going to do the opposite, the inverse, plus 10. That's gone now. Now I have this 3x. I have to divide by 3 to get rid of that 3. So everything I did to undo this function, I applied to this original x, and you end up with the inverse, x to the fourth plus 10 over 3, which is that. So yeah, it worked. Quickly, we're going to do the same thing for g. We're going to find the inverse of g. Ooh, that didn't work. So pretend we don't know what f is. To find the inverse of g, again, start with an x when you're doing this, and then look at g. And undo everything. So the first thing you're going to have to do is undo the division. So you're going to have to multiply both. You're going to have to get rid of this 3, by multiplying it. Because multiplication is the inverse of division. So you just multiply 3. So we have this x to the 4th plus 10. Now we have to get rid of the 10. So we're going to have to do that with subtraction. So it was plus 10 over here. Get rid of it by subtracting 10. And then we have x to the 4th left. So we have to undo this to the 4th. The inverse of raising something to the 4th is 4th rooting it. So you 4th root everything. And when I don't know if I made this clear on the problem, but whatever I do here, I'm doing it to everything. So I'm not going to 4th root the x. I'm not going to 4th root the 3x. I'm going to 4th root everything. So I'm not sure how clear that video was, but practice these, you'll see. That's basically it. I have one more thing, though. One more thing about the graph. So the graph is, and it will be quick, I swear. One thing about inverses is their domains and ranges are always opposite. So if you look at these two functions, the domain of this green function, which is g, is, you can see it starts at 0. And you can do this with this is my domain line, I guess. So the domain starts at 0 and goes on forever. So the domain is 0 to infinity. That should match the range of its inverse function. So its inverse function is the red. The range is y. So here's my y line. As soon as it hits it, it's y equals 0. So the range is 0 to infinity. So it matched the domain of its inverse function. And vice versa, the domain of the red function, figure out where it starts on the x-axis. It looks like it starts around, I'm going to say 1, 2, 3. Let's just say 3.5, even though that's not exact. So it's the domain of this red function is 3.5 to infinity. That should match the range of its inverse function. So now we're looking at the green function. So the range is where it exists on the y-axis. So it starts at about 1, 2, 3.5 and goes to infinity. So that shows you that the domain and range of a function and its inverse are just reversed. So that's all I got for you. Hopefully that wasn't too long, but I hope more that helps with your understanding of inverses. Thanks for watching.